So, what if I told you that chatbots are, like, officially obsolete?
I mean, honestly, I'd say that sounds a bit extreme.
Right. Especially since we literally just spent the last few years slapping chat interfaces on absolutely everything.
Yeah, every single website, every app.
Exactly. But if you look at this new statistic from Gartner, it's pretty wild. By this year, 2026, 65% of enterprise AI deployments are shifting completely away from conversational chatbots.
Wow. 65%.
Yeah, totally moving away. And instead, they're transitioning to these autonomous, multi-step things called agentic workflows. And the real kicker here, organizations that make this shift are seeing an average ROI improvement of 340%.
340. That is, I mean, that's just a staggering shift.
It really is. So to understand how that is even mathematically possible, welcome to our deep dive today. We're going to be unpacking a really fascinating roadmap from AetherLink.
Yeah, the AetherLink guide, it's really good.
It shows exactly how European enterprises are basically ripping out their legacy systems and rebuilding them from the ground up.
And, it goes far beyond just being a fun tech upgrade. If we connect this to the bigger picture, the focus of this guide is heavily on Oulu, Finland.
Ah, right, the Silicon Valley of the North.
Exactly. I mean, Oulu has this massive 2.3 billion euro digital economy footprint, but more importantly, the innovators there are currently solving the exact multi-agent orchestration and, well, compliance problems that every European enterprise is frantically scrambling to figure out right now.
Because of the regulations, right?
Yeah, exactly. They're trying to get ahead of the phased enforcement of the EU AI Act. So this transition to agentic workflows, it's not just nice to have, it's actually a strict regulatory imperative.
Which is fascinating because Ulu really has this perfect DNA for it. You've got all that legacy telecom heritage from the Nokia days, right?
Oh, yeah, definitely.
Mixed it in with this cutting-edge health tech and fintech scene. So they deeply understand complex, highly regulated systems.
It's absolutely do.
But, to really grasp why this region is pivoting so hard, we kind of need to unpack the technology itself. Like, we hear the term AI agent thrown around constantly.
It's the buzzword of the year.
Right. And to me, a traditional chatbot is, well, it's basically like a customer service rep locked in a room with just a phone.
That's a great analogy.
Thanks.
Well,
I mean, they can only answer the specific questions you ask them, and they have literally no ability to actually fix your problem in the back end.
yeah, they just read off a script.
Exactly. But an AI agent in 2026, however, is like taking that same rep, giving them the keys to the filing cabinet, a company credit card, and like the actual authority to sign contracts.
Right, it has actual tools.
Yes. It plans multi-step workflows, it talks
Yeah.
directly to your databases, and it adapts on the fly.
And that distinction between just having a conversation and actually having agency, that's the core of this entire movement. But, it introduces a pretty massive architectural challenge.
Oh, I bet.
Because if you give one single giant monolithic AI the keys to absolutely everything in your enterprise, it becomes this severe bottleneck.
And probably a huge security risk, too.
Exactly. It becomes a massive single point of failure. So the solution that the AetherLink guide outlines is something called an agent mesh architecture.
Okay, an agent mesh.
Yeah. We're moving to a decentralized network where you have these highly specialized, smaller agents that actually negotiate with each other and delegate tasks autonomously.
Okay, wait, let's unpack this for a second. How do multiple project managers avoid stepping on each other's toes? Like, I want to visualize that negotiation. Are they literally messaging each other behind the scenes, or is it more like a relay race where one hands a baton to the next?
Well, it's actually much more dynamic than a relay race. In a true mesh architecture, these agents share localized memory spaces.
Interesting.
Yeah, and they pass structured parameters back and forth based on their specific roles. And the adoption numbers for the frameworks powering this are just exploding right now.
Like which frameworks?
So according to the Stack Overflow 2026 developer survey, LangChain saw its adoption among European developers increase by 280% year over year.
280%, that's huge.
It's massive. And LangChain basically acts as a universal adapter. It's the framework that allows an AI to actually hold a tool, like securely connecting to your SQL database or triggering an external API.
Ah, okay, so LangChain gives them the hands to actually do the work.
Exactly. And then you have frameworks like Crew AI, which, by the way, is up 342% among Nordic startups.
Wow.
Yeah. And Crew AI is specialized for collaborative, role-based agent teams.
So it manages the team dynamics.
Right. It provides the logic for how Say, a research agent knows exactly when to hand its findings over to a drafting agent. And it defines how a review agent can kick that draft back if it spots a hallucination or an error.
That makes a lot of sense.
And because the architecture is decentralized, it provides this incredible resilience. Like, if the research agent fails to pull a specific data point, the error is isolated. It doesn't cascade and crash your entire enterprise backend.
Oh, I see. You can just plug a new specialized agent into the mesh without having to redesign your entire core logic.
Exactly. And that modularity totally explains the speed. I mean, Oulu-based companies using these mesh architectures are reporting 30 to 40% faster time to market for new autonomous workflows compared to traditional microservices.
30 to 40% faster. That's a massive competitive advantage. But, bringing this back to the CTOs and developers who are listening to this deep dive right now, giving these agents the quote-unquote keys to the filing cabinet brings up a really glaring vulnerability.
Oh, for sure. The hallucination risk.
Exactly. If they are operating autonomously, pulling data, making decisions without a human, how do we actually stop them from making things up? Because if an autonomous agent confidently invents a false policy and, I don't know, applies it to 1,000 customer accounts in an hour, you're getting sued under the new EU laws.
You're absolutely getting sued. And that brings us directly to the memory and compliance foundation of these systems. To operate legally, these agents simply cannot rely on the broad, generalized knowledge they were originally trained on.
Because that data is too unpredictable.
Right. They require a mechanism called RAG retrieval augmented generation.
Okay, RAG. I want to push back on RAG for a second, kind of playing the role of a skeptical CTO here.
Go for it.
Because we hear RAG pitched constantly as this ultimate silver bullet. But fundamentally, isn't a RAG just a glorified internal search engine for the AI?
I wouldn't call it a glorified search engine, no.
But it searches your proprietary documents, grabs a paragraph, and pastes it into the AI's prompt, right? Why is the AetherLink architecture team calling this a non-negotiable compliance foundation rather than just, like, a neat search feature?
Well, calling it a search engine drastically underestimates both the technology itself and what the EU AI Act actually demands from businesses.
Okay, how so?
Because RAD doesn't just do basic keyword matching. It utilizes vector databases. It essentially translates your company's PDFs, internal policies, client histories, into mathematical coordinates, these high-dimensional vectors.
Vectors, right.
And this allows the AI to map the deep conceptual relationships between documents. So when an agent faces a really complex workflow, it retrieves the precise, semantically relevant data chunks and injects them into its context window before it takes any action at all.
Okay, meaning it turns text into numbers so the AI can actually map context rather than just looking for a matching word on a page.
Exactly.
So it actually understands the relationship between, say, a specific banking regulation and a unique customer profile.
Right. And that conceptual mapping is exactly what satisfies the legal requirement. Under the new EU laws, transparency and documentation are strict, non-negotiable mandates.
You can't just have a black box anymore.
No, you really can't. If your AI makes a decision, let's say denying a loan or triaging a patient, you legally have to be able to prove exactly how and why it arrived at that conclusion.
And ARD does that.
ARD provides the auditability. It leaves this immutable paper trail showing exactly which internal document the agent retrieved to justify its action.
Oh, wow. So a modern multi-agent system would have to use that at multiple layers then.
Oh, absolutely.
Like at the planning layer, the orchestrator agent uses ARG to retrieve historical business roles just to figure out how to break down a task.
Right.
Then at the execution layer, a specialized agent accesses the client records to actually do the work. And then at the evaluation layer, the system uses ARG again to assess its own actions against your documented compliance standards before it finalizes the output.
Exactly. And the data proves just how effective that multi-layered approach really is. A 2026 McKinsey survey found that 78% of high-performing organizations are now deploying RAG-enhanced AI agents.
78%?
Yeah. And those implementations reduce compliance violations by a staggering 94%.
94%? That's practically eliminating the risk.
Well, for a European enterprise today, a 94% reduction is literally the difference between thriving and being fined out of existence.
Absolutely. Okay, so a RAG solves the memory and the auditability piece of the puzzle. But the rest of the EU AI Act, it isn't just a blanket set of rules.
This is very tiered.
Right. It uses a risk-based classification framework. It breaks AI systems down into 4 categories: prohibited risk, high risk, limited risk, and minimal risk.
Exactly. So prohibited risk involves systems that, manipulate human behavior, or execute discriminatory decisions.
Yeah.
Basically, agents simply cannot operate in those spaces.
Full stop.
Full stop. High risk covers sectors like healthcare, employment, and critical infrastructure. And that requires rigorous impact assessments and flawless audit trails.
Okay.
Limited risk mainly carries transparency obligations, meaning the system just has to disclose to the user that they are, in fact, interacting with an AI. And minimal risk just requires standard documentation.
See, I look at those categories and I immediately see massive gray areas.
Oh, they're everywhere.
Like, think about an enterprise deploying an agent to handle customer billing disputes. Is that limited risk because it's quote-unquote just customer service? Or is it high risk because it's making actual financial determinations about a person's account?
That's the exact debate happening in boardrooms right now.
Right, and trying to retrofit an existing older AI system to safely navigate those boundaries, that sounds like an absolute nightmare.
It is a nightmare, which is why these Ulu startups are succeeding. They're doing the exact opposite of retrofitting.
What do you mean?
They embed what the AetherLink guide calls governance checkpoints directly into the architecture from day one.
Okay, governance checkpoints.
Yeah, these are hard-coded decision points. So instead of the agent executing the final financial determination in that billing dispute example, the workflow automatically pauses.
It just stops.
It pauses, and it triggers a webhook that alerts a human expert on a secure dashboard. The human reviews and validates the high-stakes action, and only then is the agent allowed to complete the execution.
Here's where it gets really interesting, though. You would naturally assume that adding all these regulatory checkpoints, pausing for human review, and maintaining all these vector databases would slow the enterprise down to an absolute crawl.
You'd think so, yeah.
But the guide highlights something totally counterintuitive. Building these guardrails actually makes the systems run faster over time.
It does. It forces clean data lineage.
Exactly. You cannot have spaghetti code in a multi-agent mesh. The agents have to be perfectly organized, with crystal clear parameters and strict API contracts, so that architectural discipline ends up making scaling the rest of your enterprise software far more efficient.
Compliance forces architectural discipline. I love that. When you have an environment where every single data pull is auditable, and every agent role is strictly defined, adding a new service doesn't break the legacy system.
Which is brilliant. So theory and regulations are great, but if building these compliance guardrails actually results in cleaner code, how does that translate to the real world, like the bottom line?
Let's look at the numbers.
Right, because we can see the exact financial impact if we look at this incredible live business case study from the guide. It involves a Finnish fintech startup based in Oulu that fully automated its loan processing.
Yeah, this is a perfect example.
They had this legacy rule-based system that was slow, clunky, terrible, and they replaced it entirely with a multi-agent framework.
And it's important to note, they chose the Mistral agents framework specifically for this.
Right, and they built 3 highly specialized agents to handle this loan workflow. First, there's the compliance agent. Its entire job is simply to validate the applicant's data against regulations like GDPR and the EU AI Act.
It doesn't look at the money at all.
Exactly. It doesn't evaluate the financial risk. It only cares about the legal rules. Then second, the risk assessment agent. This one uses a proprietary RAG system connected securely to the bank's internal databases to actually evaluate the applicant's creditworthiness.
Makes sense.
And finally, the decision agent. It takes the output from the first 2 and either auto-approves the low-risk cases or it routes the complex applications directly to that human governance checkpoint we just talked about.
And going back to what you said earlier about Mistral, the choice of the underlying model for those agents is so vital here. Mistral AI is Europe's leading AI company.
Right.
The Ulu startup chose them for data sovereignty. Mistral offers sovereign EU-compliant models that allow enterprises to train on their own proprietary data sets while keeping all of that data strictly within European infrastructure.
Which is huge because data sovereignty is a massive bottleneck for US-based cloud providers right now.
Exactly. For a fintech company dealing with highly sensitive financial records, sending that data across the Atlantic to servers in another jurisdiction is just a total non-starter under the new regulations.
So by deploying this 3-agent Mistral system locally, the results are basically what's driving this entire 2026 market shift. Listen to this. Loan processing time dropped from 8 days to 4 hours.
From 8 days to 4 hours. That is a phenomenal reduction in friction for the end user. And obviously that directly impacts customer retention.
Oh, entirely. And from a risk perspective, compliance violations dropped by 99%,
Yeah.
simply because every single decision was auditable back to the ARG
That's
sources.
the paper trail in action.
But even more impressively, the cost per decision dropped by 67%.
Wow. So they achieved EU AI Act compliance at the exact moment of deployment, no retrofitting required, while simultaneously cutting costs by over 60% and accelerating the service delivery.
Exactly.
That case study is just the perfect synthesis of the agent mesh architecture working exactly as intended.
It really is. Cutting the cost per decision by 67% fundamentally changes the math on deploying this at an enterprise scale. You're moving from a really rigid software license model to a variable but highly optimized compute model.
But that variable compute model brings up the hidden trap of this whole ecosystem.
Yeah, the token costs.
Yes. Think about your own cloud infrastructure bill right now. Now imagine an autonomous agent getting stuck running in a loop overnight because it got confused by a single prompt.
Oh man, you could wake up to a 5-figure cloud bill by Tuesday morning.
Easily.
Yeah.
The guide highlights this major operational risk: agent token consumption. It is the invisible utility bill of the AI world.
Right, because every single step costs money.
Exactly.
Yeah.
Every time a large language model reads text or generates text, it processes it in chunks called tokens.
Right.
And you pay for the compute required to process those tokens.
Okay.
With a traditional chatbot, a user asks one question, the bot generates one response. It is a single, predictable transaction. But an autonomous agent is constantly thinking.
It's evaluating.
Right. It plans a step, which costs tokens. It evaluates a database tool, which costs tokens. It checks its own work against the compliance rulebook, which costs more tokens.
So if you have a mesh network of thousands of workflows running 24/7, the token burn rate can become absolutely astronomical.
It can bankrupt a project.
So if we have all these workflows running constantly, how are these Ulu developers preventing that from bankrupting their entire IT budget?
Well, they're utilizing several really rigorous cost optimization strategies from the get-go. The first one is intelligent model routing, which is essentially agent specialization.
Okay.
You do not use your most expensive, smartest AI model for every single tiny task.
Right. It's like you don't hire a senior neurosurgeon to schedule your hospital appointment.
That is a brilliant way to put it. You use a smaller, highly efficient model, like Mistral 7B, for basic routing, parsing structured data, simple tasks. And you only call on the massive computationally expensive model like Mistral Large when deep, complex reasoning is actually required for an edge case.
That makes total sense. You fit the compute power to the complexity of the task.
Exactly. Implementing that routing logic alone drastically cuts the token burn rate.
Are there other strategies?
Yeah, the second strategy is semantic caching for the RAG data.
Catching.
Right. If multiple agents across all these different workflows need to access the exact same compliance rulebook thousands of times a day,
Yeah.
you don't want them pinging the vector database and processing those exact same document tokens every single time.
Right. You'd be paying for the same text over and over.
Exactly. So you retrieve it once, you cache the semantic context locally, and you share that across the agent steps.
That's incredibly smart.
Furthermore, organizations are utilizing local execution.
Like on-premise servers?
Yeah, running lightweight agents on-premise for simple decision trees. And that incurs virtually zero marginal token cost once the hardware is up and running.
Wow. So by combining intelligent routing, semantic caching, and local execution, enterprises are reporting a 40 to 60% reduction in LLM-related expenses. And that's with absolutely no loss of agentic capability.
None at all. But, optimizing the cost doesn't guarantee the agent will actually succeed at its core job.
Fair point.
The guide mentions one final, crucial piece of the puzzle: evaluation.
Ah, right.
Uh,
Automated evaluation testing.
Yes. It is mandatory. You cannot just deploy a multi-agent system into a live enterprise environment and just sort of hope the agents negotiate properly.
Fingers crossed.
Right? No.
Oh.
Organizations are using specialized solutions like the AetherDV frameworks to rigorously test their agents in synthetic environments before they ever touch real customer data.
I'm curious, though, in a multi-agent system where they're dynamically talking to each other, how do you even test if the workflow is efficient? Like, are they just measuring how fast it runs, or is there an actual way to track the logic steps?
They test across multiple specific dimensions. So first, they measure the task success rate, which tracks how often the workflow completes its objective without a human having to intervene at all.
Okay.
Then they test the hallucination frequency. They do this by actively injecting tricky edge case prompts to see if the agent fabricates an answer or if it correctly triggers a fallback protocol.
Basically trying to trick it.
Exactly.
Yeah.
They also monitor latency latency profiles to see how the agents communicate under heavy server load, and they track the exact token consumption per workflow to ensure that cost efficiency we talked about remains perfectly stable.
So by automating this evaluation layer, these Ulu enterprises are effectively reducing their regulatory risk and operational failures to near zero in the sandbox before deployment.
Precisely.
It really paints a picture of AI development moving far away from, experimental prompt engineering and into highly disciplined, rigorous software architecture.
It's growing up.
It really is. Well, we've covered a tremendous amount of ground today, from the death of chatbots to the rise of mesh architectures, vector databases, and of course, navigating the nuances of the EU AI Act. As we wrap up this deep dive, what would you say is your number one takeaway from all these sources?
I'd say my biggest takeaway is a fundamental shift in perspective regarding governance.
How so?
Well, for a long time, the tech industry has viewed regulation, specifically the EU AI Act, as a massive roadblock. It was seen as something that just slows down innovation and burdens developers.
Oh, definitely.
But what the developers in Oulu are proving right now is that the EU AI Act is actually an architectural blueprint. By embracing RG systems for real auditability, establishing those human-in-the-loop checkpoints, and utilizing sovereign models like Mistral, compliance transforms.
From a bug to a feature.
Exactly. It changes from a burdensome post-deployment bug into a built-in feature. It actively forces you to build better, more reliable, and much more scalable systems.
Compliance as a blueprint, not a roadblock. I love that. For me, my number one takeaway is just the sheer speed of transformation and the undeniable ROI.
The numbers are wild.
They really are. Multi-agent orchestration isn't some abstract sci-fi concept for the year 2030. It is delivering 3 to 5 times ROI improvements, slicing processing times from days to hours, and reducing operational costs by 67% right now in 2026.
Today?
Yeah. The AetherLink guide makes it very clear. Organizations that fail to adopt these agentic frameworks aren't just missing out on a neat software upgrade, they are facing active, competitive obsolescence.
The baseline of enterprise efficiency has permanently moved.
It has. But before we go, I want to leave you with something to ponder that kind of builds on everything we've just discussed today.
Okay.
We talked a lot about agents evaluating other agents to ensure compliance, right? The compliance agent checking the decision agent. But as these multi-agent mesh systems become more and more autonomous, able to negotiate and optimize themselves, what happens when an orchestrator agent realizes there is a bottleneck and decides it needs to dynamically write the code for an entirely new specialized agent role that human developers never even anticipated?
Oh, wow.
Right? If an AI system recognizes a flaw and just builds a new agent to fix it, how do you audit an employee that invented itself?
That raises a profoundly important question for the next era of AI governance.
It certainly does. Thank you for joining us on this deep dive into the AetherLink guide. For more AI insights, visit aetherlink.ai.